We talked about describing the data entities in terms of the data tables and any other entities in the data product, and also about the importance for the geographic coverage and the temporal coverage. The last category of metadata that's really important to reuse of the data is how the data was collected. And in EML terms, that fits under the category of methods. If we go to the methods section, you'll see that you can add more than one step in the methods, but each step is pretty simple. The only thing you're required to provide is a description. So that leaves a lot of leeway and a lot of decisions about what belongs in the methods up to you as the data product creator. So if we go back to our code, we're going to want to add a section for the methods. And I tend to put this section after the data entities because typically I'm clarifying the shorthand version of the methods that are describing the entities in the tables with the method section. I feel like it's providing more information beyond the metadata that's available in describing the data tables. So if I go to the end of this, after our data entities metadata, I'm going to need to find a first order. Yeah, here we go. Here's a first level heading. I'm going to copy and paste this down here at the bottom. And I'm going to call this my methods section. And in this methods section, I typically like to think about two different subsections that can become part of a methods description. And in this case, I break it down into measurement methods. So I'm going to have a new subsection. That's the first subsection of this first level section called measurement methods. And then another section, data processing. And this one I will need to increment the header number. The idea of breaking the methods down this way is to talk first about how the raw data were collected in terms of the measurement methods, and then get into describing how those data were processed to generate the data product, which is the idea of the data processing methods. So in terms of the measurement methods section, this is going to be where we could refer to information about our protocol. For example, if you recall, when we built this data product, under our protocol folder, we had a folder called field, and in that field is this checklist that's basically a summary of the protocol that we use for collecting this data product, or collecting the raw data for this data product. So I might put in a statement something like this, where descriptions of the protocol followed for deployment and recovery of the instruments are available in the file, and then give the path to the file in the protocol directory. So the README file does not necessarily have to have all of the metadata, but it should refer the user to all of the metadata they need to be able to find for reproduction of the data product. So this is just an example of referring to a protocol that might be included with the data product as opposed to just listing the protocol directly here in this README file. Now there's some information that we might want to include here that's really important that we might even want to reiterate even if it's already in the protocol. In this case, just a quick description of how the PAR transducer was mounted, just so people have some idea of where this data was collected relative to the ground surface. So I've specified here that the PAR transducer was mounted with zip ties to a T-style fence post, resulting in the sensors being approximately 1 to 1.5 meters above the ground. And also another thing that's really important is typically these PAR sensors are mounted to point straight up or directly at the zenith. And in our case, we really weren't that worried about getting absolute PAR for a vertical mounted PAR sensor. So we weren't super careful about measuring the angle at which the PAR sensor was mounted. because we just needed relative radiation through the day. So I think it's important to note that because somebody using this data might assume that it's mounted as a typical radiometer would be in terms of being exactly mounted to point directly upward. And we just didn't mount it that way. So we want to make sure people who are using this data know about that. So we put it near the top of our measurement methods to make sure that's clear. So I can't remember if that's something that was listed in our protocol or not, but it's something that's really important for people to know. So I want to make sure I put it here. Also, this is our opportunity to present some cross-references to the methods that we provided as part of the column attribute metadata for the data columns, or for the data table columns. So I might want to add some subsections here, and I'll just add a little statement before them to say the following cross-references to column attribute metadata provide more detail for the methods briefly described there if needed or where needed. So that means I could have some subsections for those metadata. So if we look at that metadata and we go to the attribute table and method, oh, looks like I've already got it in the screen, but I'll just type it again. Metadata. These are the methods of the metadata that we described for the column attributes in our data table. The first one is for the time, the second one is for the par data, and the third was for that QA code, that quality assurance code. So this first method saying a Campbell program using a data logger real-time clock, I'm not sure that bears any more explanation. That's pretty straightforward. The time that is produced in our data table is just coming from the data logger's real-time clock and is relayed into the data using the Campbell program. I don't know what else to say about that. But these other two probably bear a little more explanation in terms of what they represent. So for the second column, the par column, I might want to include information like this. So again, I'm going to start a new third level header for a subsection of this second level section. And that header is going to have the column name. And again, I don't want to hard code this because I have that information in my metadata. It's the variable column of my metadata table for this table. And in this case, that's just going to be par. And then for that, I am going to be talking about this metadata attribute table and the method for that particular column, that second column. Or I'm sorry, the second row of our metadata table. And if I look at what this is, just to be clear, I'm going to copy and paste this into the console. This is the one that says Campbell data logger calculation of a 5-minute average of 30-second interval radiation measurements from a light course sensor. So I can be specific about what I mean by that. I can say the data logger was programmed to take par measurements every 30 seconds and log the average of those measurements every 5 minutes. Also, I can, again, make a reference to other information that's available in the data products. I can say the program for the data logger that includes that calibration constant for the par sensor is included in this file, and I can give the path to that file. If you recall, we can go back to the input, and the data logger program was something that we decided was one of the inputs to this particular data product, or the generation of this particular data product. So that gives us a little bit of a clarification on that brief mention of a method that we had in our column attribute metadata. And we can do something similar for the third column of our table that has that quality assurance code in it. And again, I'm just doing the same thing here, except I'm incrementing my third level section number by 1 because it's the next third level section after this one. But in this case, I'm talking about the third column. So I'm looking at the value in the third row. So I'm looking at the variable listed in the third row of my metadata table and the method in my third row of the metadata table. And if we look at this one, just to remind ourselves of what that is, it's the judgment of field technician based on the field instrument deployment protocol for deciding what that QA code is. So I'm saying here that quality control codes indicate the reason for missing data or judgment of the technician regarding any concerns about the data. And here is where we want to make sure we list what the values are. So if you recall, if we look at the type of this particular column, so I'm going to go to the, I think it's form. The form of this metadata, of this column is categorical, which means it's going to be some string of characters that represents a particular category. If you remember, there are two categories for this. And right now, all the people who are using these data are going to see are those three-letter codes we used for those categories, and they may not have the slightest idea of what those mean. So this is our opportunity to provide a table, and I'm not going to force you to watch me type all this code out, but here's where we might want to provide a table in our report or in our README file that lays out the two different codes they're likely to see and what those codes mean. And those codes are going to be one of two things. The code NKP, the description of that code is no known problems with the reported value, or the other code UEM means that there's an isolated unknown equipment malfunction that resulted in a lack of reported data. So these are some of the types of things that you want to think about including under the methods section. In particular, the things that produced the raw data in your data product. How did you get to the point where you had the raw data? So let's take a look at what this looks like when we render our markdown. Now I have a section 4 called methods. Again, the numbering is automated. And I have our measurement methods section 4.1. I have that information that I provided. And then 4.1.1 is talking about cross-referencing our PAR method. And here in bold, I put asterisks around it to make it bold. Here's the method that was listed in the column attribute metadata. And then here is the more detailed description of what that means. Same thing for the QA field. What was listed in the column attribute metadata is judgment of field technician, etc. And here is our more detailed description of what those codes mean that they'll find in that column. So let's go back to our R code and our metadata, our markdown file. Now we have this other section to think about that is about our data processing methods. So this is where we get into describing what's going on in the pipeline. And maybe we want to start this with a little bit of a general description of what these other folders are in the pipeline. So I'm going to, first of all, copy from my notes. A little bit of a description of what the input folder is, what the protocol folder is, what the incremental folder is, and what the product folder is. And I'm not going to read these to you because hopefully you've got a good feel for what these are now. But maybe we want to start our data processing just making sure that people understand in general what they'll find in those folders. But that's really not good enough for them to really know what's going on in those folders. So we probably want to give a little bit more of a description of what's going on in each of those folders. And that should at least, if not more information, be a description of the contents of those folders. So again, here's another case where we might have some third level subsections here for this second level subsection that we're working with. And these subsections might list the contents of the different pipeline folders. So here I'm listing the contents of the input folder. And then I'm creating a list in Markdown that's listing the folder. So if I go to my input, I have a folder called Data Logger Downloads. I have a folder called Data Logger Program. I have a folder called Equipment Test and a folder called Field Notes. And we haven't actually filled all these folders, but that's just an example of what you might find or what you might decide to put in an instrument deployment data product. And under data logger downloads, I have these two files that have the raw data that were downloaded from the equipment. Under data logger program, I have the program file, the CR300 program, CR basic program for the CR300 data logger. And we can do this for our other folders in the pipeline. Our protocol folder is next. So I've got the next third level subsection, contents of the protocol folder. And we can look through what's in that folder. We have the field subdirectory, the lib subdirectory. The field one has our checklist with our protocol information, as well as our calibration information for our LICOR sensors. The lib folder, if you recall, has a little bit of extra code that we're using for calculating the theoretical solar radiation incident on our atmosphere coming from the sun at our site. And then we also have these files in the protocol folder that include our .r profile, our RStudio file. Those are our project-related files for using RStudio, and also our processing file, our processing R markdown and our processing rendering script, as well as our metadata R markdown and our metadata rendering script. All of these files should be described so that somebody has a chance of figuring out how this all works. You could do a little more work here in terms of being more specific about how it all works, but this is the minimum that you probably want to provide just to make sure that everybody knows the contents of all of the different files that are provided in the pipeline folders for this data product. I'm missing one. I got one more folder that I forgot. I skipped past somehow, and that's the incremental folder. So let's make sure we get that in there. So this is the last third level subsection for contents of the incremental folder. And what's in there now is this metadata R data. That's our incremental metadata. That's where we're collecting our metadata through the workflow, the metadata that we ultimately need to put it into our README file. And also this processing notes, which is another rendered R markdown that is giving us the report on the actual data processing that we did to get from the raw data and the input into the table and the visualization and such that are in the data product folder. So if we save this then, and we render our README again, we can refresh this. Now we've got our second subsection of our methods called data processing methods. We have this preamble here that tells us something about the nature of the pipeline, and then we dive into the detail of the contents of each of the pipeline folders. And because we formatted with Markdown list formatting, we can see we have lists as well as sub-elements of that list. Recall that you can do that in Markdown based on using a dash at the beginning of the line, and then everything as long as you don't have any blank lines, everything will be included in the list. And if you want sub items of an unnumbered list, you just have to make sure you indent by at least 4 characters, and that's going to give you sub items of that list. So that's why these are sub items of this first item of the list. Just a good way to do a hierarchy of a folder structure, folder and file structure. So that's a quick overview of the type of content you want to put in your methods, and how you might want to break it up into what you did to gather the raw data versus what you did to process the raw data.